Hi everyone, it's Wednesday, so I thought I might do a bit of a data analysis for everybody so you can see how we might go about this. I think I'm going to check out the Australian Bureau of Statistics because that's a fun website to play around on. They're quite good about that, they have a lot of statistics. Let's have a look at, say, key economic indicators. Labour force and demography looks like fun. We've got a number of sets here we could be looking at. Employed persons, let's have a look at this. So we've got our key figures here over the last few months, along with our graphs. Let's see if we can find some data to download. Come on, lads, you've got data here. Downloads, here we go. Okay, let's try labour force status by sex. So all I've done here is I've just clicked on the Excel file over here. And we wait for the rural internet to cope with that. We can see that's downloading down here. Okay, that's ready. I'm just going to open that up. Okay, so we get our workbook from the ABS directly. Come on, ABS, you can do it. Let's see. Yep, perfect. Yes, okay, we'll just leave that. Sorry, this is all a bit fun. Okay, let's have a look. Here we've got our data. Now we've got a number of variables here. This is a time series data set, so we can see here it goes from February 1978 all the way down to June 2016. Okay, and the reason why that's there, there's a frozen panes there, so you can scroll up and down but still have your data labels and things at the top here. Okay, now let's pick a variable. How about if we try employed total persons? That would make sense. Now, one of the things I like to do when I first start out on a data analysis, I'm just going to call this data analysis, is I often like to graph things. So, whoops, wrong one. Here we go. Let's highlight this, and we're going to go to Insert. Yeah, just going to check that I'm recording. I am recording. Good. Insert. I hope I'm recording this. Let's try a line graph. Generally speaking, line charts for data analysis of time series. You'll see some really cool radar charts sometimes, which are very awesome, but it's a bit beyond what Excel can do. Look at that chart title. I'm going to copy that. Oh, Excel has left the building. Okay. I'm going to copy that. I'm going to put it over in my data analysis sheet because life's too short. So we're going to say this is employed persons. From, what was the date? The date was 2016 to 78. Okay. 1978 to 2016. Now, this here doesn't make a lot of sense. This is not making a lot of sense. I mean, you can't really have parts of a person who are employed. I'm not a huge fan of that. That's been done because of some smoothing. We'll leave that for the moment. However, what we could really use here is an appropriate x-axis. So I'm going to go to Select Data. Okay, that's fine. Now what I want is some x values. So I'm going to highlight from February 1978 down to June 2016. Press OK, and there we go. We've got a much better version there. We could go through this and change the decimal points here, but I'm just going to leave that for the moment. Now, one of the things we want to do is a data analysis. So I'm going to go to Tools, Data Analysis. I discussed in one of the other videos how to make sure you've got that. We don't want to do any tests yet. We don't want to do a Fourier analysis. Let's just go to descriptive statistics. Okay. Now the input range in this case is going to be doesn't like doing that at all, does it? Okay, so it's going to be 1978 down to June 2016. We group by columns. We don't have labels. I didn't highlight the label here. I'm going to put the output range over in my data analysis sheet here. I'm going to put it Nice big spot for it there. It can go somewhere in there. I do want summary statistics. We'll talk about confidence levels later and KS largest and smallest, but let's see what we get out of this. So total persons employed. Okay, so we have a mean. So over this time period, the mean is 8,652 people employed. Now, what is this area over? This is the trend. It's not seasonally adjusted. Look, this is just the time series we've got. 461 observations. That's really important, okay? So always know how many observations you're dealing with in case you have any that are missing. Okay, the standard error is a little different to the standard deviation, and that's what we want for this one. The standard deviation is 1,791. Kurtosis and skewness, we haven't talked about it a lot. There is some positive skewness, which means that the tail is heading out towards the right. We can actually do a histogram of this just to see what it looks like. We should be able to compute that. The minimum was 6,005. The maximum was 11,933. Now, if I was presenting this to somebody, I would actually put that with 2 decimal places. People tend not to like 2 decimal places, except for the count here, which really needs no decimal places. Okay. Now, I'm not surprised there is no mode here. This is continuous data, so it's much less likely that there will actually be a mode. If I was presenting that, again, I would just get rid of that. I never put an NA into a table. Now, if I am presenting data analysis, I do not present a table like this. I only present the statistics that I'm going to talk about. The sum, I never talk about. It's just not relevant in this case. Now, as we can see, this is trending upwards quite strongly. That's population growth amongst other things. So a mean by itself is not a particularly useful way of describing this distribution. However, we'll discuss that in week 10. Let's just do one more graph, or rather, let's do a histogram. So if we go to tools again, data analysis, we'll do a histogram. I haven't got a bin range, have I? No, okay, it's going to be a very long video if I try and do that. I've got another video on doing a histogram, so we'll leave it be. So that is how we can get the descriptive statistics out for our for a continuous time series variable. Thank you for listening along. I'll be posting some more on the discussion board later.